Hello everyone, my name is Kunal and currently I am pursuing BTech degree in Department of Aerospace Engineering and I am your mathematics mentor and today we are going to start the second lecture of indefinite integration uh, in which we actually look into some stuff like how to approach the integrals, how to approach the complex integrals. Like yesterday we look into some problems too. And so first of all, we are going to recall the things that we are read in the lecture one. Okay. So we will study about the basic sign of the integration, what are called integral, what are called integrand, what is elementary element of integrals, what are constant in integrals, and some property, some basic property of integration. And what we look into is some basic example on each and every single property. So today we are going to start our second lecture, which is mostly based on the like how to approach the integrals. So we are about to start. Like some of the complex integral integrands are given in question. So there are some basic technique to approach it. Like each and every single problem in this world, we need a certain approach to perform the work. So in same case, like to calculate the integration of given integrand of any kind, we have certain kind of technique to approach the problem. Basically, what we do, like sometimes in question, the given integrand is not in our loving form. Okay, so we just use this technique to convert into our favorable integral, which we know like how to integrate. So these are some technique of integration we named as substitution. We do some substitution with our integrand. We use by parts, the rule of by parts, which is also called product rule. We use partial fraction. It's basically for P by Q form, and we use some miscellaneous technique which we gonna read further in further lecture. So today we are gonna start the first technique of approaching the integrand. I'm again repeating what we do. We just convert the integrals into favorable integrand. Okay. So now the first technique is our using substitution. So like it's a अगर ये समझ नहीं आए तो एग्जाम्पल से समझ में आ जाएगी but it's the basic kind of thing that we are gonna understand that. So let us suppose that f is a function of x and this is integrand, fx is integrand, and we are integrating this integrand with the elementary element dx. And now what we do, we substitute the value of x as a function of something z. What I do, I just substitute the value of x as a function of z. Now, if we now when we substitute a value, we need the fx in term of phi z and dx in term of dz, because if f is a function of x, so its elementary element will be dx. So if x is a function of z, so its elementary element will be dz. So what I do is, if we differentiate this function, I is equal to integral of fx dx. So what we get, di by dx is equal to fx. So this is our value of fx. And when we do dx by dz, so what we get, the phi prime z. And when we substitute in our integral here, integrand here, So what we get, the f, and what is the value of x here? We substitute x is equal to phi z. So f phi z, and what is the elementary element dx here? So the elementary element dx is equal to phi dash z dz if we cross multiply here. So here we get di by dz. This also by cross multiply we get the same thing, like dx by dz है and is equal to phi dash z है. So if we cross multiply it, we get the elementary element in terms of dz, because f is a function of x, so its elementary element will be dx, and x is a function of z, so its elementary element will be dz. अगर समझ नहीं आ रहा है so एग्जाम्पल आगे आएंगी, उससे क्लियर सारी चीजें हो जाएंगी. Now the I wrote the integral I is equal to, now look at this ones. Our integrand fx is changed now. We substitute x phi z. So phi z comes out the place of x, and dx is equal to phi dash z dz. How it come? It just come by differentiating this x in terms of z, because when we substitute x is equal to phi z, our elementary element changes dx to dz. Our new elementary element is dz. So when we differentiate it, we get the value of dx by dz in terms of z. We differentiate this x in terms of z. So what we get, dx by dz here is equal to phi dash z. So if we substitute the value of dx, so what we get, phi dash z dz. So this is our new integral. Now I look into one of our example. So look at this. What is it? It is a function given, which is a function of x to the power n dot f dash x dx. Okay, so let me write here what is ever given, our function fx. So if we substitute fx is equal to t, what I do, I just substitute the value of fx is equal to t. So what we get here, I is equal to, okay, let me erase it. So my integration changes to t to the power n, because I substitute fx is equal to t. We do this substitution. Now, how we substitute it? Like I put the fx is equal to 2, and when we differentiate this function, with respect to x, we both side differentiate with respect to x. So what we get, f dash x, we are actually differentiating both function with respect to x. We get f dash x is equal to dt by dx. And now if I look into this, if we multiply both side by dx, so what I got is f dash x dx is equal to dt. F dash x dx is equal to dt. If you not multiply, we can't basically multiply, but if we like, we can write it as, look, wait, t to the power n, wait, here we can write dt. If you're not getting, so let me explain again. What I do, I just substitute the value of fx is equal to t. So we get the t to the power n, and we just differentiate this function with respect to x both side. So what we got f dash x is equal to dt by dx. F dash x is equal to dt by dx. So if we substitute here, like dt by dx, let me write again, if you're not getting. So if we substitute here, like if you mark, I just repeat this process. I do nothing more than this. So when we do that, what I got dt by dx, what we got is dt by dx is equal to f dash x, right? So when we write that, which is actually is f dash x, and when we multiply both side by dx, we get f dash x dx of t to the power n dt. And when we integrate it, what we got, this is our favorable form, t to the power n integration is our favorable form. So what I do, this is our just complex integrand. We just converted into a simple integrand, a favorable integrand by just the method of substitution. And what is its integration? T to the power n plus 1 divided by n plus 1 plus constant. Okay, so this is our basic integration. I hope you all get that. Okay, so look at its solution. Fx is equal to t. We're just differentiating with respect to x. So f dash x dx is equal to dt. And now we just get the same result. T to the power n dt, t to the power n plus 1, its integration. This is our favorable integrand. Okay, so at last we just put the value of t, which is written as fx. So fx to the power n plus 1 divided by n plus 1. I hope you understand this problem. And we saw many more example here, like how to approach any integrand through substitution method. Now, look at this example. There is a complex integrand given, sine of cos x dot sine x dx. Sine of, let me erase it first. Okay, so here is a complex integrand given, which is sine of cos x dot sine x dx. So we have to approach this integrand by the method of substitution. So what we do, we know that the differentiation of cos x is minus sine x, right? So if we substitute this cos x as some function t, u, whatever you want, so cos x is equal to t, we substitute. So we know the differentiation of cos x is minus sin x. So minus sin x dx is equal to dt. What we do, we just differentiate this both function with respect to x. So cos x differentiation with minus sin x is equal to dt by dx. So we cross multiply, we get minus sin x dx is equal to dt. So now we substitute this into our original integrand. So we get sine t because we substitute cos x is equal to t, and the rest of the sine x dx will come from differentiating the substituent value. We got minus of dt because sine x dx, and here we got minus sine x dx is equal to dt. So we get minus of dt. And now our this complex integrand converted into a simple integration of sine t, right? This complex integrand is converted into a simple function of simple integration of sine t. And we know the integration of sine t is minus cos t. So the minus cos t into this is our, this is according to our second property, which we did yesterday, which like k, what is it? It is like k times fx dx integration k fx dx integration is equal to k times integration of fx dx. So here the value, so this is our function, something function of t, and this is our k. So we will take it outside the integrand, and the integration of sine t is minus cos t. So minus of outside of integrand, and minus minus got plus. And now we again substitute the value of t, which is we put the cos x initially. So cos of cos x. I hope you understand that. So this is the basic, like how to approach the uh, complex integrand. So what I do, I just do some substitution and convert into a simple integrand. Now the second question is e to the power x plus x. So if we substitute e to the power x as t, and we know that the differentiation of e to the power x is e to the power x itself, we know that the differentiation of e to the power x is e to the power x itself. So when we substitute that e to the power x as t, so this integrand did change as e to the power t, and ex dx is our dt. If you not understand, let me clear it. First I have to erase that. Okay. And now, okay, look at this. What I do is we substitute e to the power x as, so our integration changes to e to the power t. And when we differentiate this function with respect to x, on differentiating, what I got, e to the power x, differentiation is e to the power x dx is equal to dt. Okay. So the rest of part, e to the power x dx, is come into a favorable form, which is dt. And we again know that the differentiation is, this complex function is converted into a simple function of the integration of e to the power x or e to the power t with the elementary element dt. So its integration is e to the power t itself plus some constant, because it is a family of parallel curves. And now we again substitute this value. So e to the power, what we substitute? T is equal to our e to the power x. So e to the power x and plus c. I think you got this point. Let me erase that if you got that. Now let's move on to the third question. Let's move on to the third question. So this is again a complex integrand, cos of function and cos of ln x divided by x dx. So it's again a complex function. So how to approach this problem is like, we know that the differentiation of ln x is 1 by x, right? The differentiation of ln x is 1 by x. So if we put this ln x into some function f t, whatever you want, so what we get? We get 1 by x dx term as a, like if I substitute ln x as a t, so we get dx by x as dt, because the differentiation of ln x is 1 by x. Okay, so let me solve that. Okay, so what I do, I just put ln x is equal to t. You can put any value. Let me put some new variable u. So when we okay, this is our integral. Okay, so when we differentiate it, what we got is, what we get is 1 by x dx. हमें ये मिला is equal to du. So how our new integrand look like? Our new integrand look like something cos a, cos t, and the rest of part is dt, a simple dt, right? So the uh, look at how the technique of substitution help to it solve the complex integrand into a simple form. So what we do, cos t dt, it is a simple integration, and its integration is sin t plus c. The integration of cos t is sin t. So sin t plus c. And what we substitute here, the value of, oh, sorry, a blunder. There is u, because I substitute a new variable. So our elementary element is also du and sin u. I hope you understand that. Okay. So sine of ln x plus c. Okay. I hope you understand this. So now we move to the next question. And next question, let me erase it first. So this is a question like x to x cube Okay, okay, so this is our function which look like x cube divided by 1 plus x to the power 8 dx. So this is also a complex integrand. It's not the favorable integrand we know actually. मतलब बेसिकली ऐसा है कि ये इंटीग्रेंड हमें इजी तो है नहीं बिकॉज इट्स कॉम्प्लेक्स इसकी कोई डायरेक्ट इंटीग्रेशन नहीं है. फेवरेबल इंटीग्रेंड उसे कहते हैं जिसकी हमें डायरेक्ट इंटीग्रेशन फॉर्मूला पता हो. बट इस इंटीग्रेंड को देख के ऐसा कोई डायरेक्ट फॉर्मूला दिमाग में नहीं आ रहा. सो वी हैव टू कन्वर्ट इट इनटू अ फेवरेबल इंटीग्रेंड विच वी एक्चुअली नोन, जिसकी इंटीग्रेशन हमें पता हो. सो व्हाट वी डू, we can write this x to the power 8 as x to the power 4 whole square. It's the basic rule of exponent, like a to the power m to the whole power n. You can write it as a to the power mn, right? So we use this similarly for this x. We can write x to the power 8 as, either we can write x to the power 4 whole square, right? So now, now look it into this. What we do is, so we we have to just substitute, like in numerator there is x cube and there is x to the power 8, which we can write it as x4 whole square. So we know that the differentiation of x to the power 4 is 4x cube. The differentiation of x to the power 4 is 4x cube. So if we look into this problem, so if we substitute x to the power 4 as t and we differentiate this function with respect to x, what we get? We get 4x cube dx is equal to dt. And when we substitute this value here, so how we get, like dx is equal to dt by 4x cube. Like if we substitute here the value of dx, so dx will be like dt divided by 4x cube. This is the value of dx actually we get from here. And if we put here x cube got cancelled because one in numerator, other in denominator. So what we get? We get dt 4 1 plus t square, because we substitute x to the power 4 is equal to t. So here we get t square, right? And we know the integration of 1 by t square is tan inverse of t. The integration of tan inverse, the integration of 1 by 1 plus t square is tan inverse of t. Okay, so basically, look, let me write that, because if we differentiate this integral, we got the, what is the differentiation of tan inverse of t? So the differentiation of tan inverse of t is 1 by 1 plus t square, right? So therefore, the integrand of, so when we integrate the 1 by 1 plus t square, we got the value of tan inverse of t. And again, we substitute here, t is equal to x to the power 4. So we get 1 by 4 tan inverse x to the power 4 plus some constant. I hope you understand this question. Let me write some more basic formula of integration of inverse function. So let me raise it first, like integration of dx by 1 plus x square is equal to tan inverse of x plus some constant. You have to actually remember these all, some basic. So now the second thing is dx by root under of 1 minus x square sine inverse of x. Let me write that, sine inverse of x plus c. These are some basic formula which you have to remember. So we actually what we understand till now. So we have if we have some given complex integrand, so we have to convert it into a simple favorable integrand by the technique of substitution. And the favorable integrand जिसकी हमें integration पता हो. I hope you understand that. So now we move to the next example. And our next example, wait, try to remember these both. These are important actually for general use. One of more I want to write it like if it is in the form of integration of dx. You also know that, but let me write again when you read in actually differentiation like dx by mod x root under x square minus 1 is nothing but sec inverse of x. Sec inverse of x plus constant. So these are some basic formula of integration. So now if you wherever you look these kind of integrand, so try to write indirect. Like if you अगर तुमने देखा कहीं like dx by 1 plus x square का integration है, so it's directly written into tan inverse of x plus c. Its integral is tan inverse of x plus c. Okay, so now try to remember these three of formula. Now we have to move to the next problem. Okay, so now let's move to the, so this is our problem given, another integrand. The fifth question is x square tan inverse of x cube divided by 1 plus x to the power 6. So like how to approach this? So we know that the differentiation of tan inverse x is 1 by 1 plus x square. So if we put tan inverse x cube as t, if we substitute the tan inverse x cube as t, so what we get here? We get 1 by, like this is, wait, tan inverse of x cube here, right? So whatever here, we apply the chain rule here, the basic rule of differentiation in which you आपने पढ़ा होगा chain rule. So we just apply here and the 1 by, so the differentiation of first tan inverse x cube is 1 by 1 plus x square. So 1 by 1 plus x cube to the whole square. And now we differentiate x cube with respect to x. So we get 3x squared dx equal to dt. We just apply the chain rule here. First, we differentiate the tan inverse of x cube with respect to the function x cube. And then we differentiate x cube with respect to x. So we get 1 by 1 plus x cube to the whole square dot 3x squared dx dt. So if we substitute here, so what we get actually? We get t by 3 dt, right? T by 3 dt, how? Because we substitute the tan inverse of x cube as t and the rest of part x squared dx by 1 plus x to the power 6, x squared dx 1 plus x to the x to, this is by basic rule of exponent, a to the power mn will be like a to the power mn. So it will be equal to dt by 3. So our complex integrand is converted into a simple form of integrand, which is t dt by 3 by the technique of substitution. I hope you understand that. And this integration will be like t square by 2. So 1 by 3 t square by 2 plus constant, which we get t square by 6 plus constant. And now we substitute like tan inverse of x cube will is equal to t. So our integral will be 1 by 6 tan inverse of x cube whole square. I hope you understand this problem. Now I am Now move on to the next problem. Problem number 6. So what is it? This is a complex integrand again. Let me erase that. Hope you write some basic formula. Okay. So here, move on to the next problem, which is like tan root x sec square root x by root x dx. So we know that the differentiation of tan root x is basically the differentiation of tan x is sec square x, right? So here is a function tan root x, which is a complex function. Okay. So so when we differentiate this function with respect to x, we have to use chain rule. So first we have to substitute this tan root x as t. Now the things is कैसे पता चलेगा हमें कि हमें tan root x को ही सब्स्टिट्यूट करनी है. तो हमें ऐसा करना है कि यहाँ पे हमें इंटीग्रेंड दी हुई है, राइट? सो वी हैव टू कन्वर्ट दिस इंटीग्रेंड into a new integrand and elementary element and elementary element. So we know that the elementary element is in the form of dx or dy, whatever it is. We have to convert. So we know that the differentiation of this tan x will be sec square x और वही फॉर्म में दी हुई है. So we have to substitute this. We don't know if we substitute sec square root x as t and we differentiate it. So the differentiation of sec square x is like first we have to differentiate it is with using chain rule with respect to sec x. Then we have to differentiate sec x. So we didn't get a favorable elementary element. So we have to substitute the tan root x as some variable ut, whatever you want. And now move on. So now differentiate this function tan root x with the chain rule. So what we get, first differentiate this function with respect to root x. So we get sec square root x, and when we differentiate root x with respect to x, what we get 1 by 2 root x and dx is equal to dt. So here we get the differentiation by chain rule sec square root x, and the differentiation of root x is 1 by 2 root x dx is equal to dt. And now try to substitute here. So what we get, we substitute tan root x is t, and the rest of the values sec square root x by root x dx is 2 dt. So again here it is converted to a simple form of integrand जिसकी integration हमें पहले से पता है. So it will be like t square by 2 and 2 get cancelled. So it will be basically like t square plus some constant. And now again we write this function tan t is equal to tan root x. So tan root x whole square plus constant. I hope you understand this problem. Now move on to the next problem. So our next problem is again like ln x plus, it's again a complex. It's again a complex integrand जिसकी हमें integration direct नहीं पता है. So what we do, we just use the method of the first method of basically our first method or जिसको technique which is substitution. So if we substitute this ln x plus root under 1, look, the chapter integration or the calculus is more and more based on practice. It has less theory. Practice the question makes you like perfect in this. कैलकुलस की सबसे खास बात यही है कि आप जितने ज्यादा प्रैक्टिस करोगे, जितनी ज्यादा प्रैक्टिस करोगे, सवाल उतने ही अच्छे समझ में आएंगे क्योंकि इसमें थ्योरी कम है. थ्योरी में अभी तक हम लोगों ने क्या पढ़ा है, हमने बेसिक थ्योरी में क्या पढ़ा है, सम बेसिक फॉर्मूला एंड सम प्रॉपर्टी एंड नथिंग मोर. हम जो भी कर रहे हैं लाइक अभी तक जो हमने बेसिक कैलकुलस इंडेफिनिट इंटीग्रेशन में पढ़ा है, व्हाट वी रीड, सम बेसिक फॉर्मूला, some basic property And today we start some basic technique to approach the complex integral. इसमें पहली पार्ट पढ़ रहे हैं अभी हम, substitution one. So I will suggest you rely more and more on practice the question. Okay. So now we move on to the next question, which is ln x plus root under 1 plus x square by root under 1 plus x square dx. So if we substitute this function as something ut, whatever you want, and when we differentiate this function with the help of chain rule, so what we get? The differentiation of ln, let us say it is u. So when we differentiate with this function with respect to u, so what we get? 1 by x plus root under 1 plus x square. And then we differentiate this function with respect to x again. So 1, and the differentiation again here we have to use the chain rule. So first root x will be differentiated at 1 by 2 root x. And then we solve that, we get the value dx by root under 1 plus x square dt, because the same thing comes out in numerator and x plus root under 1 plus x square in denominator. So both get cancelled and we get the dx by root under 1 plus x square is equal to dt. So our integrand converted integration of t dt, which is like t square by 2, its integration is, and now we put the value, so we get 1 by 2 ln x plus root under 1 plus x square whole square. I hope you understand this problem. Now we move to the second problem, eighth problem, which is as tan to the power 4x dot sec square x dx. So we know that the differentiation of tan x is sec square x. We know that. So if we put the difference tan x is equal to t, so sec square x dx is equal to dt, differentiate it. So what we get? T to the power 4 dt, because this whole part sec square x dx of our integrand is converted into dt. And this is our the favorable integrand, which we know, which we already read in our basic formula of integral of integrand. So what is its integration? Raise 1 power and whatever we got divided by d. So we get t to the power 5 by 5. And again substitute the value. So 10 to the power 5x by 5 plus some constant. Now move on to the next problem. Problem number 9. Try to solve this problem by own, and if you not, look into its solution once. So I'm moving forward. I hope we solved some 8 problem on substitution technique. Look, हमें दी हुई होंगी इंटीग्रेंट, हमें बस इतना पता करना है कि उसे अप्रोच कैसे करनी है. सो आज के जो क्लास में हमने पढ़ा है टेक्निक टू अप्रोच द इंटीग्रेंट, द कॉम्प्लेक्स इंटीग्रेंट. तो हमने सब्स्टिट्यूशन पढ़ा, एंड तो सब्स्टिट्यूशन पे 8 क्वेश्चन करे एंड ट्राई टू सॉल्व 9, 10, 11, 12 whatever you are given by own, and if not then look into its solution once. Calculus is more and more over depend on practice. It has less theory. Okay, so now move to the next part. Now some basic formula. We have to extend our basic formula list by these 4 too. So what is the integration of tan x? We actually know the integration of sin x is minus cos x. Integration of cos x is sin x. So what is the integration of tan x? Since we know that if we differentiate the integral, we get the integrand, right? So there is some function. So how to approach this? So what we do is tan x integration will be like ln sec x, cot x integration will be ln sin x, sec x integration will be ln sec x plus tan x or ln tan pi by 4 plus x by 2. We further look into its proof too. Cos x integration will be like ln cosec x minus cot x is equal to ln, but basically same. These and these are same. So now how to prove this? So we can write this tan x as sin x by cos x, right? And we know that the differentiation, of sin x is cos x. And the differentiation of cos x is minus sin x. So if we substitute the cos x as some function f or t, so this whole part comes into dt. Look, let me write it. What I'm trying to say is, what I'm doing is we have to find the integration of tan x. So what I'm doing is we can write tan x as sin x by cos x. Sin x by cos x dx. And if we substitute this cos x as t or whatever I want, cos x as t or u, let me substitute u, any variable, you can substitute any variable. So differentiation is minus of sin x, differentiation of cos x is minus sin x dx is equal to du is equal to du. So our integration of tan x is changed to 1 by t dt minus we can take out by the second property of integration. So minus 1 by t dt. And we know the integration of 1 by t is ln t. So minus ln t plus constant. So here we get minus ln, what we substitute here, cos x. So ln cos x plus some constant. Okay. And we know that by the basic logarithmic rule, like this, the the number which is written outside the left side of the log, if it goes inside, it goes into its power. Like if it's written k log x, so we can also write it as ln x to the power k, right? So here we get ln 1 by cos x. So 1 by cos x is like sec x. So its integration will be like ln sec x. So what we do, we just integrate this tan x integrand with the help of substitution method. We can write tan x is equal to sin x by cos x. We substitute cos x is equal to some function f, t, u, whatever you want. And then we find differentiation. We convert the elementary part to our new elementary element. And then we integrate. So we get the ln sec x plus c. I hope you understand that. Similarly, we can write cot x as cos x by sin x. We can write cot x as cos x by sin x, and then we integrate, and then we substitute sin x as t, u, v, whatever you want. So its differentiation will be cos x. So its differentiation will be cos x, and then we proceed on. Let me tell you how to proceed there. Okay, let me tell you the proof of cot x1. Okay, so cot x1 will be the simple. Okay, so what I have to do is, like we can write cot x as cos x by sin x, cos x by sin x dx, and we substitute here sin x is equal to t, sin x is equal to t, and if we differentiate this, what we get cos x is equal to cos x dx is equal to dt, cos x dx is equal to dt. So again we get 1 by t dt, this time positive 1. And when we integrate this, what we get? ln t, and we substitute the value t as sin x. So ln sin x is our integration. I hope you understand that. I hope you Understand that. So the integration of cot x is ln of sin x. Now we move to the next part, sec x. So wait a second. Let me erase it first and try to remember this formula. These are some basic formula like the first class formula and the today's class formula, like integration of 1 by 1 plus x square is tan inverse x. Integration of 1 by root under 1 minus x square is sin inverse of x. Integration of 1 by mod x root under 1 x square minus 1 is sec inverse of x. So try to remember these and this four formula. So let's move on to the next part, which is sec x. Integration of sec x dx is ln sec x plus tan x. So how to prove it? So first we have to write that sec x is sec x plus tan x. Sec x, try to multiply it by sec x plus tan x and divide it by sec x plus tan x. Okay. So now we move and now try to substitute sec x plus tan x is t. We differentiate it. The differentiation of sec x is sec x tan x plus x square x. The differentiation of tan x is sec square x dx is equal to dt. So when we move to the next part, so what we get dt by t and its integration is ln t and we substitute the ln is sec x plus tan x. So ln sec x plus tan x is its integration. And when we move to the next part, what we get the sin x plus we can write it as 1 by cos x sin x by cos. Let me write that. If you not understand, let me write that. Listen. Sec x plus tan x, sec x plus tan x, we can write it as sec x plus tan x, we can write it as 1 by cos x, 1 by cos x, sin x by cos x, sin x by cos x. So we can write it as 1 plus sin x, 1 plus sin x by cos x. And now we can write this 1 plus sin x as, this 1 plus sin x as sin x by 2 plus cos x by 2 whole square. How we can write it as? Because look, this one we can write it as sin square x by 2 plus cos square x by 2 and its value is 1. X by 2 plus cos square x by 2 and its value is 1. And the 2 sin x by 2 cos x by 2 is sin 2x. So sin 2x cos square x by 2. And we can write this sin x will be like 2 sin x by 2 by basic trigonometric formula of sin 2x, whatever you want, sin x by 2 cos x by 2, right? So we can write it as sin x by 2 cos x by 2 whole square. And cos x we can write it as, by this substitution, cos x square by 2 sin x square by 2. Because the cos 2x value is cos square x minus sin square x. So we just follow through it. And when we proceed, we get the result tan pi by 4 x plus 2. Okay. So hope you understand this. Similarly with cos x, just try to multiply and divide by cos x x minus cot x. And similarly, it cos x dx proof is similarly to sec x. So we get ln cos x minus cot x. So these are some basic examples which we will discuss tomorrow on this. So try to remember today's basic formula, whatever I taught, and try to solve the problem 9, 10, 11, 12 of substitution technique. So tomorrow we will start with these problem and move on to the second technique, which is by parts. Okay. Thank you, everyone.